Hey guys, so this is the Algebra 2 1.3 notes on linear functions, characteristics, and properties. The first topic that we're going to talk about is finding intercepts and rate of change from graphs and tables. So in the first example, it says Isabel is filling a tank. The graph shows the amount of water in the tank versus time in minutes. And the first question asks you, what is the amount of water in the tank at 0 minutes? Well, if you look at your graph, so we are looking at 0 minutes. If you look at your graph, you can tell from the graph that the point at 0 minutes that actually hits the graph is right here where I just plotted with the yellow, and that's at 80. So my first answer says, what's the amount of water in the tank? Well, the amount of water in the tank at 0 minutes is 80 liters, according to the graph. Then it says to choose the statement that best describes how the time and amount of water are related. So it's easy to tell how these are related based on the graph. If you're looking at the graph from left to right, what's happening? As time increases, so as you're looking at the graph from left to right, as the time goes up, what's happening to the amount of water in the tank? Well, the amount of water in the tank is also going up because it's increasing from left to right. It has a positive slope. So this has a positive slope increasing from left to right. So your answer here must be this one. As time increases, the amount of water in the tank also increases. It then asks you at what rate is the amount of water increasing? Well, when it talks about rate, it is asking for the slope of your equation. When we have to calculate the slope, what we're going to do is we're going to pick 2 points on the line. So I have this point right here is at 1 and 320. And then I'm going to pick this point right here, which is at 2 and 560. So you're going to pick those 2 points, and you may recall that in order to find the slope or the rate in an equation, that you're going to use the y2 minus y1 over x2 minus x1, which is the slope formula. So if you look at the examples of the ordered pairs that I found on the graph, and we use those, we can calculate what the rate is. So we have y2, I'm going to call the 560. So we have 560 minus the other y, which is 320, all over 2, which was with the 560, the x2, minus 1. So you have 560 minus 320 is 240, and 2 minus 1 is 1. So our answer here for the rate is 240. Okay? So that is the most work that you're going to have to do with that type of problem. Let's look at the next one. So in the next one, it gives you a table of values of a linear function, find the slope and y-intercept of the function, and then write the equation. So when we are finding the slope based on a table, we have to figure out what the slope based on the table is the change in y over the change in x, okay? So we have to figure out what the changes are. So the changes in the y from 5 to 8 is plus 3. From 8 to 11 is plus 3. So the changes are always plus 3. And the changes in x from negative 1 to 1 is plus 1. From 1 to 1 is plus 1. So knowing that, we're going to put the y's on top, which was 3. The x is on the bottom, which is 1, and 3 divided by 1 is 3. So we found out that the slope of this equation is 3. Okay? The y-intercept of the equation is where x is 0, because the y-intercept is the point on the y-axis. So we want to look for where x is 0, and that happens to be at this point right here. So that tells us that the y-intercept in our equation is in fact 8. So remember, when we go to write our equation, that all equations of linear functions are written in the form y equals mx plus b, where m is the slope and b is the y-intercept. So we write our equation y equals 3x plus 8. And there's our final answer there. In the next set of problems, they're asking us to find the domain and range of the functions. So remember, domain and range, as it is highlighted up here, domain is all the possible x values of a function. So domain stands for the x values of a function. So looking from left to right. And range is all of the possible y values of a function. So looking up and down. So the range is always the up and down, and the domain is always looking the left and right. And similar in this equation, saying that the independent variable is like the domain, and the dependent variable is the output, or like the range, okay? So if you look at our first example, take a closer look at our first example, okay? We see a picture of a graph and it's asking for the domain and range of that graph. So I'm going to use blue for the domain. So remember, domain is the value, the x values of the graph. So if I look at this closely, the x values here start at 0. Start at 0, that's the x value at 0, and they actually end at 90 on the x-axis. So how I would write this domain is in the form of an ordered pair or an inequality. They want you to write the form using inequalities. Is I'd say, well, the x values are in between 0 and x. So 0 is less than or equal to x, which is less than or equal to 90. And that's how we would write that using inequalities. Okay. If I look at the domain, the range of the function, which I'm going to use yellow for, remember range is up and down, and it's the y values at that point. So notice that that y value starts at 60. That first point is at 60, and the second point is at 150. So when I write the range, I'm going to do the same thing as I just did above, but instead I'm going to say 60 is less than or equal to y, which is less than or equal to 150. And that tells me that it starts at 60 and ends at 150. Okay, so that's how you write domain and range using the inequalities. Let's look at another example. In this example, if I highlight where the domain is using blue, notice that it has an arrow, right? It has this arrow at the end, which means that it goes on forever. So that tells me that the range is going to go on forever as well. Or sorry, not the range, the domain is going to go on forever because there are infinite number of numbers. You don't know how long that line is going to go out. So how we would write that is we would say the domain of this function is all values of x that are greater than or equal to 0, because 0 is where it starts. That's its starting point. The range of this function is similar, right? It has that arrow at the end, so that means this linear function could go up and up forever, and we don't know how long, and it's an infinite amount. So we would say the range of this function is y greater than or equal to 0, all the values of y that are greater than or equal to 0. Starts at 0 and moves up. Okay, so that's domain and range with inequalities. And if we look at our last set of notes, it's comparing properties of linear functions given the different forms. So what you have to do for these types of problems is you have to figure out the slope. You have to figure out the slope and the y-intercept of each problem, okay, before you can answer the question, because it asks you a lot of questions about the y-intercept, about steepness, and about the slope of the equation. So you have to be able to identify what the slope and y-intercept is of each function that they give you, and then you can answer the questions. So the first function, if I want to find the slope of that function, I'm going to count. I'm going to count how many up did I go and how many right did I go. So my slope of this function is I went up 2, right 1, so my slope is 2. My y-intercept is pretty easy to find in this picture because remember it's the point on the y-axis. So my y-intercept, my b, is -2 here because that's the point on the y-axis. In the set of ordered pairs, remember the slope is the change in y over the change in x. So the change in y here, it goes down 1, right? And the change in y from -2 to -1 is +1 and +1, right? So that tells me that the slope is -1 over 1, which is 1, -1. So my slope is -1. And then remember, when you're given a set of ordered pairs, your y-intercept is the point where x is 0. So my b here is 3. The next function is in y equals mx plus b form, so it's pretty easy to spot there. The y-intercept is -4, and the slope is -3. And in the last function, it always gives you the answer right off the bat. The slope is 4, and the y-intercept is 1. Now that we know all those pieces of information, we can now answer the questions that it asks us. So the first one says, which function has the graph with a y-intercept farthest from 0? So if you look at all your y-intercepts or your b's, the one that is farthest from 0 is function 3 because it is at -4, and that's the furthest from 0. The next question says, which function of the graph is steepest? Well, remember that the further something is from 0, the steeper it is. So furthest from 0, the further the slope is from 0, the steeper the graph. So I've got a slope of 2, I've got a slope of -1, I've got a slope of -3, and I've got a slope of 4. So out of those 4 slopes, function 4 is the one that is furthest from 0, so that is the steepest graph. Which functions have graphs with y-intercepts greater than -3? Well, that one's pretty easy to tell. Negative function 1 has a graph that is has a y-intercept that's greater than -3. Function 2 has a y-intercept that's greater than -3. Function 3 does not, and function 4 does. So it's 1, 2, and 4. All right, one more example here, and then we'll be done with the topics in this lesson. So we have to find the slope and y-intercept of each of these functions. So let's find the slope of the graph. The slope of this graph would be I went down 1, 2, 3, 4, 5, and then I went right 1. So my slope is down 5 over 1, so it's -5. My y-intercept is the point right on the y-axis, so my y-intercept is at -2. Then if we find the pattern or the change in y for the slope here, we have the slope in this equation. It goes down 3, and this goes +1, so my slope is -3. And then the y-intercept is the point where x is 0, so the y-intercept in this case, or my b, is 3. In function 3, they're already pretty much given to you. So you have the y-intercept is 5 and the slope is 4, the number in front of the x. And same thing with function 4. The slope is 1, they give that to you, and the y-intercept is -4. Now we can answer our questions. So the first question says, which function has the graph with the greatest y-intercept? So you have to be careful when it says greatest y-intercept, because greatest means that it has to be positive. It has to be a positive number, because in order to be the greatest y-intercept, it has to be a positive number. It can't be negative. So out of the y-intercepts that they gave you, the one that is greatest would be function 3. In the next question, it says, which functions have graphs with slopes less than -4? So that one you can look at the slopes. Well, function 1 has a graph that's less than -4, or a slope, sorry, that is less than -4. And I believe that is it. So we just have function 1 for that one. And then question C says, which function's graph is the least steep? Well, recall from earlier that the least steep equation refers to the one that is closest to 0. The slope that is closest to 0. So slope that is closest to 0. So out of these slopes, the one that ends up being closest to 0 is function 4. So it must be the least steep graph. All right, try these practices out on Alex and let me know if you have any questions. Good luck.